What's poppin', dogs? Mr. Allen here, ready to run you through some of this wonderful lesson 1 homework here for the radicals unit. All right, so now the first section here, we got 3 questions here. Determine whether each relation is a function. I'm gonna do some problems on the side that'll allow you to try these problems yourself. Okay, so if I have a nice little graph here, let me draw one up, and let's just say I have maybe like a cubic function, a negative cubic function. We love those, yes? Now, to tell if this is a function, well, we already know it's a function. We said it's a cubic function. It passes what's called the vertical line test, okay? So if you look here, if I were to draw any line at all along this ruler here, it would only pass through that graph one time. Throw it over here. No matter what, this thing is only passing through one time. At any given spot on this relation, we know now is a function, right? And it is a cubic function. We recognize it, but there we go, okay? So that one would be a function. Now, let's say, and I'm going to take this guy off real quick. Let's say I had a different graph, okay? Let's go with something a little wonky. How about a circle, okay? How about a circle? That sounds awesome. Okay, so is this relation going to be a function? Well, in the same way, I can use what's called the vertical line test to see if it passes through more than once at any given time. And anywhere on a circle here, you can see if I were to draw a line, that yellow guy right there, or maybe I'll go a little bit darker so we can see it a little better. Whoa, I didn't get the ruler. But, oh my goodness, come on, Mr. Allen. There we go, all right. Vertical line, no matter what, it's passing through twice there. So a circle would not be a function, okay? If I were to restrict it to only like half the circle, just like a semicircle, that would end up being a function. But as it is right here, not a function, okay? Cool, fantastic, and wonderful. So are there any questions on those couple problems? No? Excellent, I'm gonna move on. Vertical line test tells me that it is a function, okay? Passes through once, it's a function. More than once, not a function. I'd write that down in your notes, okay? Now let's see here. Those were the first, actually that was the first 6 questions there. So now let's go down to the 7 through 12 here, all right? So here it asks us to sketch the graph of the inverse of each function, okay? So what the heck is an inverse? Well, an inverse would be created from a function if we swap our x and y coordinates, and it reflects over the line y equals x. Hence the switching of the x and the y. Kind of see a little thing there? I'm going to draw up a graph, okay, with another function out to the side here, and then we're going to do both of them there, okay? So the original and the inverse. All right, so let's plot this guy right here. We got y equals x squared minus 4. So it's our wonderful, fantastic quadratic that is going to be shifted down 4 points. And I'm even going to do a table of values here to help us out, okay, because it's really going to help with the inverse. Actually, let's do this one in black here, because that'll be our original, okay? So let's go with, let's see, we got x, we got y. I'm going to center it around 0 because it's not shifting left or right. And I'm going to have -1, -2, and we'll go 1 and 2. So if I plug these values in, when I plug in -2, -2 squared is 4, minus 4 is 0. If I plug in -1, I get 1 squared, well, sorry, -1 squared. That's 1 minus 4 is -3. And if I plug in 0, I get -4. And if you do remember from quadratics, you are going to see the same points show up here because 1 squared is 1, minus 4 is -3, and then 2 squared is 4. Sorry, 2 squared is 4, minus 4 is 0. Okay, lovely. So now I can plot these points. So I got -4 right here, -1 and +1, comma, -3, and then we have 0, comma, or sorry, -2, comma, 0, and +2, comma, 0. So let's sketch this thing, all right? Cool. So now we have this original quadratic function. And it's going to ask us to plot the inverse. So I want to do this in red here. If I make a new t-chart, the inverse is going to swap my x's and my y's. So for my inverse, which you can notate as y and the little -1 exponent, or in function notation, we would say f, a -1, and then x right there. That reads f inverse of x, okay? So we're just going to swap our points. So I'm going to have 0, -2, -3. I'll go all the way down here. I don't want to mix them up. Boom, wonderful. And we got -1, 0, 1, 2. So as easy as that, just swapping my x's and y's, okay? Now let's plot them. And I'm going to be careful how I say the numbers this time so I don't mix them up. So we have 0, comma, -2. We have -3, right? -3, comma, -1. We have -4, comma, 0, -3, comma, +1, and 0, comma, 2. And then I'm going to go ahead and connect my dots in this lovely quadratic. Okay. So as you can see here, it's like this, it was like turned on its side. And check this out. If I throw this guy at a 45 degree, which would be the same angle as like y equals x, just 1 over 1, okay, and I were to draw a line going through there, I'll do a light blue for this one. If I were to do that, you could see that these graphs reflect over that line. It's a little tough to see. It gets a little bit mixed up, but you can kind of see how there's some common points like right here where they're intersecting. So those two graphs reflect over that line, y equals x, okay? Now let's go back to what the actual question was from the homework there. Sketch the graph of the inverse of each function. So there we go. That was all it asked us to do, right? It just asked us sketch the graph of the inverse. So what I would do is either you can sketch the original, right? Or you can just make a table of values and swap your x's and y's, all right? So this one here, it looks like they just sketched the inverse. I gave you both on that one there. But all they did was they wrote out their table of values right here. Let me zoom in on that. They give you your table of values right here. And then they swapped their x's and y's, and they just plotted these ones right here. I'll circle this in dark blue. That's all they plotted right there on the graph. So that's all you need to do for these right here. All right, we could ask you to do both. We could ask a question on a test where we're like, hey, given this graph, sketch the inverse of the graph. The main thing here is we're swapping our x's and y's, okay? Let's keep on moving and grooving. Okay. So let's see here. Determine whether each function is invertible. Interesting, okay? How in the heck do we tell if it's invertible? Like if the inverse, what we're saying here is the inverse a function? So maybe write that down right here. Is the inverse a function? That's what we really want to know. Is the inverse a function, okay? That's what they mean when they say, is it invertible? Okay, is each function invertible? So these three here are functions. Are they invertible? Is the inverse going to be a function? Well, let's take a look back at the graph that we did over here for the previous example, okay? So for this one, the black one right there, the original one right there, y equals x squared minus 4, would that pass my vertical line test? I heard somebody say it. Yes? Yes, it would. Yes, it would pass the vertical line test, okay? So anywhere along here, no matter where I draw a line, if I drew a yellow line right here, let's see if hopefully it shows up. I know it's a little hard to see the yellow, but that line would only pass through once, okay? But now go to my inverse, right? The y inverse, the red one right there was the inverse where we swapped our x's and y's. Does that red function pass the vertical line test? Meaning, does it only pass through once and only once at any given spot? No? No. Very good. Somebody said no in the crowd. Excellent work. Yes. Okay, so that vertical line right there passes through twice. Thus, the red one is not a function, unless we restrict it to only part of the graph. Okay, well, we're going to do that a little more later in the next lesson where we're like, okay, well, if I have this function that is not invertible, can I just work with a portion of the function and be able to invert it? You can do that. But I'm getting ahead of myself. I'm excited. All right? So all we really need to do here is, well, I guess I could sketch the inverse, swap the x's and y's. That seems like a lot of work. Perhaps there's another test, okay? What do you notice about a horizontal line? How many times did that horizontal line pass through the original quadratic function y equals x squared minus 4 drawn in black? How many times would it pass through that one? Well, that one, I know we're getting a lot of colors here, that would pass through twice on that black graph right there, right? It would pass through 2 times. Only once through the inverse. Interesting. Perhaps we have ourselves a wonderful test that we can use, okay? So vertical line test, so vertical line test would be if it passes through, so that would be the test of the original guy is the function, okay? So is the original a function? If it passes the vertical line test, only goes through once, yes, it's a function. If it goes through more than once, not a function. But then we also have the horizontal line test. Okay. That's testing, is the inverse a function? Boom. There we go, all right? If it passes the vertical line test, it's a function. If it passes the horizontal line test, the inverse is a function. So let's real quick, say we have an example like this guy right here. Let me leave those tests visible. If I threw down a graph, boom, ooh, ah, boom, boom. Let's say I drew something like, let's go with the cubic. But let's do it like this. What if I did like a cubic kind of like this guy here? Does that pass my vertical line test? Whoop. And 90, yep. Anywhere I am along this guy here, my ruler is only going to pass through at one given spot. Would it pass the horizontal line test? Anywhere you go through this, yes, one given spot. So this one, the original is a function and the inverse is a function. Now, does that mean that's true for all cubic functions? Not so fast. Check this out. What if I were to draw maybe a cubic like the one we had in the beginning, something like this? This passes the vertical line test. We already agreed with that, right? Anywhere I go along here, it passes the vertical line test. Does it pass the horizontal line test? Well, if I can get it to 0. You know, we're pretty close. I'm a perfectionist. I want the 0. I want 0. Okay. It passes it up here, right? But then all of a sudden, oh my gosh, we're going through this thing 3 times. So for this one, the inverse would not be a function, okay? The original was a function, inverse, not a function, all right? So that's our horizontal and our vertical line test in action so that you can answer those homework questions. All right, guys, the last one's here. It says, without graphing, determine whether each function is invertible. Interesting, okay. Without graphing. I kind of like graphing, but whatever, man, whatever. All right, so I'm pretty sure we could come to the conclusion that any even degree, right? If I had any kind of even degree, whether it's, you know, just your y equals x squared, or, you know, when we had like y equals, like it was like, as we went like higher degrees, it kind of like flattened out right at the, and got really steep. Either way, they all look like that U shape or an N shape. Are they going to pass the horizontal line test, which would mean that it is invertible? No. No even degree functions are going to pass that horizontal line test. So if it's an even degree, yes, the original is a function, but it is not invertible. The inverse is not going to be a function, okay? And then we have our odd degrees. Well, our original odd degrees, without any kind of transformations or anything crazy like that, your odd degree ones, those are going to be invertible. But once they start getting a little more drastic, not so much. So be careful with the odds, okay? I'm going to say go ahead and just maybe graph a couple of these, but these two right here, they don't have a whole lot going on with them, so they're probably just going to do like their little bend kind of thing, right? But as we get a little bit crazier with some cubics and stuff like that, some of them will be and some of them won't be invertible. So you can't make such a clear conclusion on those, but you can with the even degrees. Even degrees, the original is going to be a function. The inverse will not be a function. We can still graph the inverse. It's just it's not a function, so it's not invertible. All right, I hope this all helps you guys, runs you through the homework there so you can get it done. And I mean, have a great day. Make sure you like and subscribe, okay? Support the channel, okay? Support the channel. All right, you guys have a great day. See ya. How do I stop this thing? I can't remember. I haven't done one of these in forever. See ya.